right, so we've already covered how to graph sine and cosine and tangent. Now we're going to touch on the graphs of the reciprocal functions, the secant, cosecant, and cotangent. Just to give you a little idea of where we're headed, the graphs of sine and cosine look like this. A little squiggly thing, we call it a sinusoid. It varies between 1 and -1, normally speaking. The graphs of secant and cosecant look like this. It's got a series of little U's that kind of look like parabolas. But that's the basic idea of the shape. And I forgot to put it on here, but tangent and cotangent have squiggly things like this. We'll get that in more detail in just a minute. Okay, so when graphing reciprocal functions, two things to keep in mind. One is that zeros and asymptotes trade places. If we have 0 and we divide that by whatever, what does that equal?
0.
0. Because 0 divided by anything is 0. Now, if we flip that and anything divided by 0 is undefined, which on a graph, when you have a value at which x is undefined, or a value of x at which the function, or y, is undefined, we have an asymptote. So, and so if you take the reciprocal, that's flipping the fraction, so any place that had a 0 on top, then will have a 0 on the bottom for its reciprocal, and vice versa. Then the other thing is, both graphs share points at 1 and -1, vertically on the y-axis. Because what's the reciprocal of 1?
1.
1. What's the reciprocal of -1?
-1.
-1. So what we do is we look for these points, these characteristics. Here's the sine function. If we want to graph the cosecant, which is the reciprocal of sine, wherever sine has a 0, cosecant is going to have an asymptote. 0, asymptote. 0, asymptote. Are there any asymptotes here?
No.
No. So is cosecant going to have a 0 at all anywhere?
No.
No. Okay. Now the other thing is, sine is 1 at each peak. Therefore, cosecant also has a value of 1 in the same places. Sine has a value of -1 here and here at each valley or trough, and so cosecant is going to also have a value of -1 in those same places. Now, let's go through the process here. As we approach 0 from the right, let's see, we are positive, positive, negative, 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 positive. As we approach 0 from the right, what is happening to the value of sine theta? Is it getting larger or smaller?
Decreasing.
It's getting smaller and smaller. So if we put a smaller and smaller number on the bottom of a fraction, what happens to the fraction?
It's bigger and bigger.
It gets bigger and bigger. So from this point, as we approach x equals 0, we are getting bigger and bigger and bigger. And the same thing, and since this is just a mirror image of that, the same thing's going to happen here. And this is going to repeat over here, so we're going to have the same thing here. And what's going to happen down here? We can think of it as a reflection about the x-axis. This point is going to be the same. Sine gets smaller and smaller on the negative side of things, therefore cosecant is going to get larger and larger on the negative side of things. And like that, and like that, and like that. So there's the graph of cosecant. Well, now that we've gone through the thought process on that one, what's the relationship between the graph of sine and cosine?
It shifted.
It's just shifted over 90 degrees. That's what the co means, right? Complementary angles are angles that add up to 90 degrees. So the sine and the cosine are related to each other with an offset of 90 degrees. So we're going to do the same sort of thing. Following our guidelines for reciprocal functions, any place that cosine has a 0, any place that cosine is 0, secant is going to have an asymptote. 0, asymptote. 0, asymptote. 1, 1, 1, 1, -1, -1, -1, -1, 1, negative 1. And we know that the shape is going to be exactly the same, just shifted over. So here we are, so we go like this, we go like this, we go like this, and we go like this. And there's the graph of secant. Pretty exciting. Now, graph of tangent and cotangent. Now, tangent has zeros and asymptotes. How very exciting. So, let's take a look at things here. Let's do one thing at a time. Let's take a look at zeros. Where tangent has a 0, here, here, here. Where tangent has a 0, cotangent has an asymptote. 0, asymptote. Put that off to the side a little bit. 0, asymptote. 0, asymptote. Okay. Asymptote, 0. Asymptote, 0. Asymptote, 0. Asymptote, 0. Now, just negative, positive, negative, positive, negative, positive, negative, positive. Shut the door, please. Thank you. All right, now, what happens? Let's see. Let's go right here. Let's go right here as the function is approaching pi over 2, approaching this this asymptote here. What is as tangent gets larger and larger and larger towards infinity? What's going to happen to 1 over tangent?
It's smaller.
It's going to get tinier and tinier and tinier. Positive or negative?
Positive.
Positive. Taking the reciprocal does not change the sign. So if we are above the x-axis here, we're going to be above the x-axis here, but as this one gets bigger and bigger, this one, as we approach the same spot, we're going to get smaller and smaller and smaller towards 0, which makes sense. We know we're going to hit a 0 here. What happens over here?
The opposite.
Let's do it right here. In the same region here, approaching an x of 0, we are coming smaller and smaller and smaller and smaller. As tangent gets smaller, what happens to cotangent?
It's bigger.
It's bigger and bigger toward this asymptote. And just in the interest of time, you can go through the same thought process, and what ends up happening with cotangent is it looks like this. So the graph of cotangent becomes you take the graph of tangent and you flip it and shift it over 90 degrees, or pi over 2. And that is how you construct how you figure out how to sketch the graphs of the reciprocal trig functions. And next time we will do graphs of reciprocals. Ta-da!